Hi, welcome back. In till now, so far we discussed about from basics, what is host, what is network, what is networking, and what is MAC address, and how to view the MAC address, and IP address classification. What is an IP address, and how we can represent the IP address, and the classification of IP addresses: Class A, Class B, Class C, Class D, and Class C. And we discussed about we have different segregation of IP addresses, that is private IP and public IP addresses, and these are the range of public private IP addresses what we have from Class A, Class B, and Class C. Okay,
Okay.
Class A, B, C. Okay, and then we gone through like what is public IP address, and where it can be used, and who will be providing that public IP address, and the differences between a private IP and public IP addresses. Okay, so here like if private IP, it can be used only inside the network. Okay, but public IP, it can be used only outside the network. Okay, is in the public network, we can say. Outside network means it's internet. Okay, so these are the range of private IP addresses what we have, and these are the range of public IP addresses what we have. So here public IP, it's a unique IP address over the globe. Okay, but in case of private IP, what happened? Okay, so these private IP addresses, in the organization, it should be unique. Okay, but this private IP address can be used by other organization also. Okay,
Okay.
so in the organization, it's unique, and this can be used for other organizations also. I can say other network also.
Okay.
So that's about private IP and public IPs, and we gone through what is network types. Okay, LAN, WAN, and MAN is there. No, so what is LAN? LAN stands for local area network. It's local to a single area, and MAN stands for metropolitan area network. Okay, so it's between two buildings in the city, we can say. So within the city, we can call it as it's a when or you can say metropolitan area network. Okay, and WAN means it's a wider area network. Okay, so wider area means it's between the cities, we can say, between the cities or between the countries. Okay, so that is called like network types. And when it comes to network topologies, we gone through what is P2P means, point to point topology, bus topology, mesh, tree, and hybrid topologies. Okay, and then we discussed about the cabling part. So let me enlarge my screen. So we need to have cables, like to if you want to connect two computers together. Okay, so we need to have a cable to share the if you want two computers or two network devices want to communicate with each other, we need to have some connectivity, that is by using cables. Okay, with respect to wide connectivity. So here we have two types of cables. One is LAN cable, and another one is optical fiber cables. So in case of
Optical fiber.
yeah, sorry, you were asking something.
No.
Yeah. So we have two kind of cables, that is LAN cables and optical fiber cables. So in case of LAN cables, the traffic will go as electrical signal, but in case of optical fiber cables, it is through light signals. Okay. So here electrical signals, if you compare with the light signal, the speed of electrical signal is less. Okay, but in case of light signals, it's very fast. Okay, so that's about different cables what we have. And next we gone through if two devices want to communicate with each other with a long distance. Okay, so there is a possibility of a signal strength reduction. Okay, so to maintain the signal strength uniformly, we need to have one device called a repeater. So here we'll keep repeater in between the devices where we want to regenerate the signal or maintain the signal strength in the uniform way. So we can say repeater is a device which can which have the capability of regenerating the signal. Okay, and then so this is the symbolic representation of the repeater, and this is how the actual device looks like. Okay, if you want to if you purchase a repeater, this is how it would be. Okay, and this is how we can use in the real time scenarios. And so if we have like a number of devices, okay, like if they want to communicate with each other, okay, so we need to have more number of cables to connect between each other. That's the first thing. And second thing is, if any new devices want to add, okay, again it's need to connect to all the other computers which are connected to it. Okay, so it's too complex. That's why we have one device called hub coming into the picture. Okay, so here hub, what it is doing, so we can connect any number of devices to a centralized point, that is called hub. Okay, so here the functionality of the hub is, whenever like let me show you here, one sec. So here like consider that it's a hub. So here like we have a number of devices. Consider that these are the devices. Okay, so here consider A, B, C, D. So A want to send information to only B. Okay, but what hub is doing, what is the, as per the functionality of hub, as soon as it receives the data on one port, okay, it forwards the traffic to all the other ports which are connected to it. Irrespective of to B, it will send to a C and D also. Okay, so that's the functionality of hub. So in a simple way, as soon, like if the data is received on one port, it will transfer or forward the traffic to all the other ports which are connected to it. That's the functionality of hub. But in case of like if you think, if you want to send some secret information to only C, from A to C, but what hub is doing, it is sending to all other computers, right? So it's a drawback. So if you want to send only like one-to-one communication, so it's a drawback, right, to hub. So we can't use hub here. So that's why we have one more device coming to the picture, that is switch. Okay, so we'll discuss about switch. So like before going to explanation of switch, this is the symbolic representation of hub. Okay, so we can represent like this. Okay, so this is how the actual device looks like if you purchase from any of the vendor who is manufacturing that. And
Okay.
yeah, this is how like the real time how we can connect, how we can use the hub. So next we have like one more thing called a bridge. Okay, so bridge also is a kind of network device. It's a network device if you want to connect two hubs together. Okay, we are using hub bridge, that's it. Okay, so like just for connectivity purpose we are using bridge here. Okay, so here we know what is the functionality of hub, we know, and what is the hub functionality, we know. Like what is the bridge functionality here? Okay, so the functionality of bridge here, it connects two hubs together to share their resources. We can say, suppose like A, B, C, D, E, F. Okay, so if you want to send information from A to D, okay, so it will, what it does, it will transfer, it will send the traffic to here, this port, and what hub does, it will send to all the ports which are connected to it. Okay, so here like we have the bridge, and bridge also like it will share the information to this hub, and again it will come here. Okay, so this like it's not like mostly used network device in the organizations. Okay, but we have this device and we need to aware of it, and this is how the bridge looks like. So if you can see here, like, it has only two ports. Okay, and we can connect two networks together. If you want to connect two networks together, we need to have a bridge device. Okay,
Okay.
so next one, like so we know what is the disadvantage of hub. It will transfer the data to all the other ports which are connected to it, right? The disadvantage of hub, or drawback of hub.
Yeah.
So that's why we have one more device, switch coming to the picture. Okay, so let's discuss about like a switch, and what is functionality.
And
Okay,
here I have one more doubt. One doubt.
yeah, yeah.
Yeah, can we connect more than two hubs or only two hubs? Must be with
To the bridge,
bridge. Yeah.
as per my knowledge, it's only two networks, I can say.
Yeah. Okay.
Yeah. So when it comes to switch, okay, so we have like consider that we have four computers, A, B, C, D. So here like we have the switch device. Okay, so that I'll tell you like the definition of what is switch. Okay, so here computer A is connected to port 1, computer B is connected to port 2, computer C is connected to port 3, and computer D is connected to port 4. Okay, so here uh, if A to C for the first time, so A is sending some information to C. Okay, so for the first time, what happened here, So A is sending some information. Okay, so while sending this information, okay, it needs to have what is source IP, what is destination IP, source MAC, and destination MAC. Okay, so it needs this information. So while sending this information, okay, so it needs its destination MAC address to reach here. Okay, I'll tell you, like why we need these details. I know we have one concept called OSI layers. Okay, so in that concept, we'll explain about, like why, I mean, where and all it's required. Okay, so for now, it needs to get this four information is mandatory to send any traffic from one to another device. Okay, so here, if you can see, we have the source IP address. Source IP address is nothing but from where we are trying to access. Okay, and destination IP is nothing but what we are trying to access. Okay, so what we are trying to access, this is the IP, this is the one, right?
Yeah.
One second. So this is the one, right? And so source MAC address is, we know, like from where we are trying to access, but we don't know what is destination MAC address. Okay, so that time what happened, we have one terminology called ARP, address resolution protocol. It will go further. Okay, so for you, just to understand what is the functionality of switch, I'll tell you here. Okay, so for the first time, if any traffic is communicating with each other, okay, from A to C, so A is sending information to switch port. Okay, A is sending information to switch port. If you can observe here, it's kind of small animation, I can say. Okay, so A is sending. Then for the first time, what happened, switch also, it acts like a hub, so it will send to all the other ports for the first time. Okay,
Okay.
so so if you can see here, so for the first time, what it is doing, it is sending the traffic to all the other ports, right, which are connected to it. Okay,
Okay.
so for the first time, it is sending. And then what happened? Okay, so what, here we have a source IP, destination IP, and port number, right? So here the destination IP is 10.3. So though the traffic is received to all the ports, so the intended, the destination, so we are sending the traffic to this IP address only, no, 10.3. So this device, what it does, it's my traffic, because I could see my IP address is there in the request. Okay, so it will send back to port 3 saying that it's a MAC address. Okay, so you can see here. So if you can see, it is responding back to switch saying that it is my MAC address. Okay, so here, if you can, if you remember, source IP, destination IP, source MAC, and destination MAC we need to have, right? So how switch basically work? Okay, first it will check its ARP table information. ARP stands for Address Resolution Protocol. Okay, so it consists of the information from IP address to MAC address. Okay, so here IP address we know, but we don't know about this MAC address, right? Because for the first time we are sending the traffic. Okay, so it's a brand new switch, considered like that. Okay, so for the first time it is not having the ARP table information. So that's why it is sending to all the other computers. Okay, so whoever IP address is this one, the destination IP address, whatever we have mentioned here, it will respond back to the switch saying that it's my, like, you are sending information to me, so it's my MAC address, save it. So that information will be saved in the ARP table. Okay, so for the second time, again A to C communication is happening. Okay, so then what happened? A to C communication is happening. So once the traffic is reached to port 1, then it checks ARP table information. Okay, so the destination IP is this one. So do you have the MAC address of it? So here it's available, right, for the second time. So that's why it
Yeah.
directly sends to computer C only. So let's see here. Okay, so here we have the ARP table information, right? So for the first time, it captured that information. So now, if second time, if A is sending information to C, so then what happened? It's directly sending to C only. It's not sending to other devices. Okay, is it clear?
Okay. Yeah.
So at the same time, let's go with some other examples. Okay, so it's not only with respect to A and B. Okay, so if you can say, not first time and second time like that. If you want to remember easily, so we can tell in this way. Okay, so if B to D communication is happening, okay, B to D. So here what happens? B is sending information to port 2, okay, And so once port 2 communication is done, then what it will check? It will check the ARP table. Okay. So as it is sending it for the first time, there won't be any information available in the ARP table. Okay. So that's why it will send to all the other connected ports. Okay.
Okay.
So what happened? Now we are sending to D, right? So by using this IP address, it will send back to the request to switch saying that this is my IP address and MAC address. You save it. Okay. So again, now what will happen here in the ARP table? One more row will be added. 192, 168, 10.4, and its MAC address is 002A. It is there now here. So it will be
Yeah.
added here. So for the second time, if it is sending again, it will check the ARP table. If ARP table we have the information available, right? So it will send back to the request to the computer D only. Okay.
Yeah. Okay.
So is it clear what is the functionality of switch? So we can say switch is also functions like hub only, but only for the first time. And from the second time, okay, or else like we can say in this way, switch is a network device, okay, which can transfer the information from one device to other device based on the ARP table information. If there is no information available in the ARP table, it forwards the packet to all the other ports which are connected to it.
Okay.
You got my point?
Yeah.
Yeah. So here, like we have, one table called, one second. We have, one more table available in switch. Okay. That is MAC address table. Okay. So MAC address table is nothing but, like on which port, which computer is what, and like, on port one, what is the computer, what is the device which is connected to it? On port two, what is the device? On port three, which device is connected? On port four, what is the device is connected? So this information is called MAC address table. So in switch, what type of tables we have? One is
Octable.
MAC address table, and another one is ARP table. Okay. So here MAC address table consists of information about the connected device to port to device, which device is connected. Okay. And ARP
Okay.
table, it's IP to MAC address of the device. Okay.
Okay.
Yeah. So let's go further. So here, like ARP stands for Address Resolution Protocol, and it consists of the information about IP address to MAC address. Okay. And we have
Okay.
one more thing called reverse ARP. Okay. So reverse ARP means it's like, MAC address to IP address, we can say. Okay.
Okay.
So like it will, like, this will help, like in case of routers, like while sending the traffic from one network to another network, we need to have this information available. We'll discuss on later on. But what is ARP and what is reverse ARP, right? Hello.
Yeah. Yes.
You got the point, right? Like what is the functionality of switch, and what type of tables we are having? What is ARP and what is reverse ARP?
Can you please like repeat one more time with reverse arc?
It's nothing. Okay, it's the IP address, MAC address to IP address. So here ARP table. Okay, what type of information we are having here? IP address and MAC address, right? So by using
Yeah.
IP address, we are finding the MAC address.
Okay.
Okay. So reverse ARP means by using MAC address, we'll find out the IP address of the device.
Okay.
So vice versa it is, I can say, in a simple way, if you want to
Yeah.
remember.
Yeah. Okay. Okay.
Okay. So here, like we have a number of devices which are connected to a switch to all the other connected ports. Okay. So it's one LAN only. So if we have only one local area network, so what we are doing, we are connecting all the devices to a centralized device that is called switch. Okay. So what if you are having like more number of networks? So here we have LAN 1 and LAN 2 is there. Okay. So if the LANs, like LAN number is increasing, okay, we won't like switch capacity, it won't having like thousands ports, all these things. Okay. So we have some limitations, right? So that's why, so this is one network and this is another network. So if you want to connect two networks together, we need to have we need to have a network device called that is router.
Okay.
So by using router, we can connect multiple networks together. Okay.
Okay.
So we'll discuss about what is router, what is the functionality later on. So for now, if you want to connect two networks together, if you okay, so we need to have a network device called router. So inside the network, we have switches.
Okay.
Okay. So we can say our hosts are connected to a network device called switch. Okay, switches are connected to router to forward the traffic to other networks.
Okay.
Okay, so if we have like more networks, so this is how we will be able to connect. So LAN 1 we have one switch, LAN 2 we have another switch, LAN we have another switch and switch. So what we are doing, we are connecting. See, for example, just mention like only around 7 systems. Okay, in general we'll be having like n number of things. Okay, it depends on the capacity of the switch. Okay, so we'll be able to connect to all the routers. So if you want to so what happened, let me tell you here. Okay, 1 second.
Here I have one doubt.
Yeah,
Yeah, suppose I need to connect with the LAN 1 to LAN 4, like
yeah,
LAN 1 A to LAN 4 D. So is it possible to get the information?
yeah. That's
Uh,
what I'm going to tell. That's what I'm going to tell now. So if consider that in LAN 1 you have computer A, and LAN 4 consider is a server. Okay, some server is there. So here,
okay.
if you want to access, like A to server, okay. So then what happen? First, you will send a request to switch, okay. So then switch, what it does, it will check for ARP table information first, right? So what is the I mean, let me tell you in this way, okay. Let me clear it out. One sec. Yeah. So consider it's a server, A computer, and B is a server. Okay, so now let's see how the traffic will go here. Okay, so if we want to send information from one computer to another computer, okay, we need to have four information we require, right? So that is source IP, destination IP,
Like source MAC address,
source MAC address, and
destination MAC.
destination MAC address. Okay, so these four information we require. So here source IP we know. So let's consider that the source IP address is 10.1.1.1. Okay, and this server IP address is 10.2.2.2. So here what is source IP and what is destination IP.
Okay.
And source MAC, here we are, from here we are sending, right? So it is aware of source MAC address, because from one device we are sending, no. So it is aware of source MAC address, but we don't know where is this network connected to. We are not aware of, right? We know only inside this network we have some information, but outside of this network we don't know where this network is connected to or IP is connected to. Okay, so we need to find out the MAC address. Okay,
Yeah.
so here first what happened, it will send a request to our switch one. Okay, then in switch one what happens, it will check for the ARP table. Okay, so for the first time it is sending, no, so there won't be any information available with respect to this IP address, that is 10.2.2.2. It's MAC address, it won't be available, right, for the first time. Are you with me?
Yeah, yes, yes.
So when for the first time if you are sending, okay, so it will check for the ARP table information in the switch. Okay, so what happened, there is no information about ARP table for the first time regarding the IP address, that is 10.2.2.2. Okay, so that's why what it will do, it will send broadcast means, like I'll tell you later on, but it will send to all the other ports which are connected to it, including router also. Okay,
Okay.
so what happened, these devices having some other IP addresses, no. The IP address what we require is 10.2.2.2, but here we have some different network at all. So it's nowhere related to this one. Okay, so they won't
Okay.
respond. And then the request will come to router also. Okay, so in the router we'll be having two kinds of information will be there. So let me tell you, the what is router. So to connect multiple networks together, we need to have router device available. Okay, so
Okay.
to forward the traffic to like we can say in a simple way. So router is a device which forwards the traffic between the networks. Okay,
Okay.
and here we will be having information about routing table. Okay, so router is a device which forwards the traffic between the networks by using the routing tables. Okay, routing table is nothing but let me tell you. Okay, so here we reach this device, right? Okay, and it will check for the destination address. Okay, so what is the address we are searching for? That is 10.2.2.2. Okay, so it will check the routing table. Okay, I'll tell you what is routing table. For now, just consider that it will check a table called routing table. Okay, so in the routing table,
Okay.
like whatever the network which is connected to it, it will be having that information. So we have four routing tables available. Four routes available in the routing table. Route 1,
Okay.
route 2, route 3, and route 4. So here the destination IP address what we are trying to access, that is 10.2.2.2, right? So it is having that information. Okay. So it's having that routing information it is having. So that point of time what router will does, router responds to request saying that take my MAC address. Okay. So router provides its own MAC address. Router MAC address. Okay. So in switch what happened? For the IP address in the ARP table 10.2.2.2, router MAC address will be saved. Okay.
Okay.
Not exact its MAC address. Okay. Router MAC address will be saved in the switch 1 ARP table. Okay.
Okay.
Then, so by using this routing table information, what router does, it will forwards the traffic to the switch because it is connected to here now.
Yeah.
So we'll be having like IP addresses configured. So by using these IP addresses, it will send to switch 4. Okay. So while sending to switch 4, it will remove its MAC address. Okay. So till here router is there. We received the information about we received this all the information now. Source IP, destination IP, source MAC and destination MAC. What it sent to router, its own MAC address, right?
Yeah.
So after reaching the router, it has to forward the traffic to the destination, right? So here the destination is connected to this switch. Okay. So here it will forward the traffic to this switch only to this switch. Okay. So while forwarding, it will remove its MAC address. It will cancel this MAC address and it will send for this only.
Okay.
So again, what happened? The traffic will reach to switch 4. Okay. So what it does? Again, it will check for ARP table. Okay. So ARP table, first time nothing will be there in the switch 4. So that's why what it will do, switch will transfer the packet to all the devices. Okay.
Okay.
So here the destination is 10.2.2.2, right? So after sending to all computers, our B server will respond to request saying that it is my IP address and I'm having the MAC address of this information. Okay. So it will provide saying that 10.2.2 is my IP address and save my MAC address as some ABC, something just like it will be long, but just consider ABC. Okay.
Okay.
So it will save that information in the switch ARP table.
Okay.
Okay. So it will follow, it will reach the destination. You got my point now? Is it clear?
Yes.
The flow.
Yes. Yes. From
So
the router, the MAC address will be deleted, and
and
again it will send to
the
switch.
the connected switch, and here the connected switch will forward the traffic to all the ports. Okay. So here we'll
From there, we
sending.
will get the MAC address.
Sorry, I
From there,
didn't get.
we will get the MAC address of the LAN 4.
Not LAN for the server what we
From
are trying to access.
yeah. Okay.
Yeah, that is the flow. Okay. For the second time they are trying to access. Okay. For the first time it's happened like this. No. For the second time if they are trying to access, it will send to switch 1. Okay. So it's already having the RP table information, right? Regarding the destination IP address 10.2.2.2. What is the the MAC address? That is router MAC address. It's already saved, right? For the first time.
Yeah.
So it will reach the router. From the router again it will go to switch. From the switch it's having the RP table information. It will reach to computer B. Similar way it happened to whatever you are trying to access between the networks.
Okay.
Okay,
Yeah.
is it clear? Or any
Yes.
doubts?
No, 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 clear.
Okay, cool. So we are having, like next topics called, network address, what is broadcast address, what is valid addresses. Okay, so we'll discuss about that.
Okay.
So before going to that, okay, like let's go with, net. I mean, yeah, I'll tell you. 1 second. Uh, yeah, let me go with, the subnet mask concept.
Okay.
Okay, so 1 second. Mm, Yeah, let me tell you, like what is network address, broadcast address only for the first time. Okay, yeah.
Okay.
So network address is nothing but, like starting first IP address of the range. Okay, so what is range? I'll tell you here. Okay, so here we have the, like, private IP addresses, right? Let's consider like this. Okay, so that it will be clear for you to understand. Okay, so we have the private IP addresses, from class A. What is the series? 10
From
series,
class.
right?
Yeah. Yes.
One sec. So 10 series, right? So 10.0.0.0 to 10.255.255.255. Okay, so this is the, like a series of, private IPs from class A. So here, like the starting IP address is 10.0.0.0, right? So that is called network address. So the first address of the network is called the network address. Okay,
Okay.
and the last address from the private IP address is, that is broadcast address. Okay, so last address is 10.255.255.255. Okay,
Okay.
and between the addresses, whatever it is there, that is called valid IP addresses.
Okay.
So first IP address is network
Network
address.
address.
Last one is broadcast address. In between the addresses, whatever we are having, those are called valid IP addresses. Okay, so here I am just referring to a full network, full private IP network from class A. Okay, we'll
Okay.
discuss about that. Okay, so from the class B, what's the subnet we are having? That is 172.16.0.02. We have, like 172.31.255.255, right? So here I'm not
Yeah.
mentioning all the things. Okay, just I'm mentioning, some subnet. That's it. Okay, so
Okay.
here the network address is starting address, and the broadcast address is the last address. Between the addresses, those are called valid addresses. Okay, so this
Okay.
network address and broadcast address, we can't assign to any network device. Okay, we are not supposed to assign broadcast address and network address to any other device. Okay,
Okay.
only the valid IP addresses, whatever we have available, only it can be assigned. It can be assigned to other devices. I can say it can be assigned to network devices or hosts, we can say. But network address and broadcast address, it can't be assigned to any network device or the host, I can say. Okay,
Okay.
and from class C, we have, 192.168.1.0 is a network address, and here 192.168 is a broadcast address. Okay,
Okay.
between addresses are called valid IP addresses. So let's go, a theory here, what I have mentioned here. So network address is the first IP address of the range. Okay, and
Okay.
it represents the complete network, and it cannot be assigned to any other networks. Okay, and here, um, no, we have network portion and the host portions are there. Okay, we'll discuss about that, in the next class. Okay, so here host portion and network portion is nothing but in the subnet mask calculation it will come. Okay, I'll tell you about this point in the coming classes. So for now, it's the first IP address and it can't be assigned to anyone. It will represent the complete network. And what is the broadcast address? It's the last IP of address of the
Contact.
range, and like it can be used to broadcast the messages. It can't be assigned to any device in the network. Okay, and if just like keep it in mind, a network address host portion is 0, and in case of broadcast address host portion is 1. It will be filled with. Okay, I'll tell you, like how why we have to fill, ones with the for broadcast, ones with zeros with, like network address. Okay, so for now you got it right.
Okay.
What is network address? What is broadcast address? Okay,
Yeah.
and the valid IP address is nothing but whatever the addresses we
Between
have
the
between network address and broadcast address is called valid addresses. Okay, so only valid IP addresses are assigned to hosts, or like a connect whatever the clients
current
we have.
devices.
Yeah. Yeah, that's all from my end for today. And in next class, we'll discuss about subnet mask. Okay, so here you'll get it, like what is the host portion, what is the network portion, all these things, we'll discuss in the next class.
Okay.
Okay.
Yeah. Okay.
Yeah.